In January 2025, an asteroid the size of a 15-story building had a 3.1% chance of hitting Earth, the highest impact probability ever recorded for any known asteroid. NASA had to activate its full planetary defense alert system for the first time in history, tracking it daily, briefing governments, and preparing response options. The asteroid was eventually ruled safe, but the process NASA used to track, measure, and prepare revealed exactly how the world would respond if the answer had been different. I remember watching the 2024 YR4 impact probability update daily in January 2025. The number kept climbing instead of falling. For 3 weeks, that asteroid sat at the top of every planetary defense watch list on Earth. It was the first time I genuinely understood that this is not a theoretical problem. NASA has confirmed there are over 35,000 known near-Earth asteroids, objects whose orbits bring them close to Earth's path around the Sun. New ones are discovered every single week. Only about 40% of the estimated population of near-Earth asteroids larger than 140 meters has been found, meaning the majority of objects capable of causing regional destruction are still undetected. NASA's Planetary Defense Coordination Office tracks every known near-Earth asteroid continuously using its automated Sentry system, a real-time database that calculates the impact probability of every detected object simultaneously. Asteroid 2024 YR4 was discovered on December 27, 2024. Within weeks, NASA calculated it had a 3.1% chance of hitting Earth on December 22, 2032, the highest impact probability ever recorded for any known near-Earth asteroid. NASA's James Webb Space Telescope observed the asteroid in infrared light and confirmed it is approximately the size of a 15-story building, large enough to destroy an entire city if it struck a populated area. By April 2025, continued observations reduced the Earth impact probability to 0.004%, effectively ruling it out. By February 2026, JWST observations also ruled out any chance of a lunar impact in 2032. NASA's primary asteroid detection tool is a network of ground and space telescopes that continuously scan the sky, comparing images taken minutes apart to identify any object that moves against the fixed star background. The Catalina Sky Survey in Arizona and the Pan-STARRS Observatory in Hawaii together discover the majority of new near-Earth asteroids. Both operate continuously, night after night, building the most complete catalog of near-Earth objects ever assembled. NASA's upcoming NEO Surveyor Space Telescope, designed to operate in infrared and detect asteroids that are invisible to ground telescopes, is in development and will dramatically accelerate the discovery of previously unknown threats. On September 26, 2022, NASA's DART spacecraft, the Double Asteroid Redirection Test, deliberately crashed into the asteroid moonlet Dimorphos at 22,500 kilometers per hour. It was the first time in history that humans intentionally changed the motion of a natural object in space. The impact shortened Dimorphos' orbit around its partner asteroid Didymos by 33 minutes, far more than the minimum 73 seconds NASA needed to declare the mission a success. 4 papers published in Nature in March 2023 confirmed the result. In March 2026, ScienceDaily confirmed new research showing the DART impact also shifted the entire Didymos-Dimorphos system's orbit around the Sun by a measurable amount, the first time humans have altered a celestial body's solar orbit. The kinetic impactor method, crashing a spacecraft into an asteroid, works by transferring momentum to the target. The key is time. A tiny nudge delivered years or decades before impact can change the trajectory enough to miss Earth entirely. DART's impact also produced a debris plume that pushed back against the asteroid, effectively doubling the deflection force beyond what the spacecraft's momentum alone would have produced. This effect, called momentum enhancement, was confirmed in the Nature papers. The critical factor is warning time. A 10-year warning allows a small spacecraft to deflect almost any threatening asteroid. A 1-year warning makes deflection far more difficult. A 1-month warning makes it essentially impossible with current technology. The European Space Agency launched the Hera spacecraft in October 2024, heading to the Didymos-Dimorphos system to perform a detailed investigation of exactly what DART's impact did to the asteroid. Hera will arrive at Dimorphos in late 2026 and measure the crater DART created, the asteroid's internal structure, and the precise mass of both objects, data needed to turn DART's one-off experiment into a repeatable, reliable deflection technique. Without Hera's data, scientists cannot fully calculate how effective a future kinetic impactor would be against a different asteroid, because the result depends on the asteroid's internal composition, porosity, and structure, which vary for every object. On April 13, 2029, a Friday, the 340-meter asteroid Apophis will pass within 32,000 kilometers of Earth's surface. That is closer than many geosynchronous satellites currently orbiting above us. Apophis will be visible to the naked eye across parts of Europe, Asia, and Africa as it passes, an asteroid large enough to cause continental-scale destruction if it struck, visible in the sky without any telescope. NASA has confirmed Apophis will not hit Earth in 2029 or in the following century. The United Nations designated 2029 the International Year of Asteroid Awareness specifically because of this close approach. The closest a known asteroid of this size has ever come to Earth in recorded history. If an asteroid with a genuine impact probability above 1% is confirmed, NASA's Planetary Defense Coordination Office immediately notifies the White House Office of Science and Technology Policy, which coordinates the U.S. government response. The International Asteroid Warning Network, IAWN, connects planetary defense teams from NASA, ESA, JAXA, and dozens of countries to share tracking data and coordinate response options in real time. The 2024 YR4 alert was the first genuine test of this network at full activation. The UN Committee on the Peaceful Uses of Outer Space, COPUOS, has published a formal response framework outlining the decision chain from detection to potential deflection mission approval. This framework was tested and refined during the 2024 YR4 alert period. For very large asteroids or very short warning times, kinetic impactors may not provide enough deflection force. NASA and the U.S. Department of Energy have jointly studied nuclear deflection, using a nuclear device detonated near the asteroid's surface to vaporize material and push it off course. This is not the Hollywood scenario of blowing an asteroid apart, which would create a shotgun blast of fragments potentially more dangerous than the original object. The nuclear option uses the energy to deflect, not destroy, by creating a powerful push from one side. During the 2024 YR4 alert, one research team published a paper proposing a nuclear deflection mission as a precautionary study, peer-reviewed and taken seriously, though ultimately not needed as the probability fell to near zero. China has announced plans to perform its own kinetic impactor deflection demonstration, similar to NASA's DART mission, with a launch scheduled for 2027 and an observer spacecraft to document the impact results. This is significant because planetary defense ultimately requires global capability. No single nation can protect Earth alone. A Chinese deflection test would give the scientific community a second independent dataset confirming how effective kinetic impactors are. JAXA's Hayabusa 2 spacecraft, which returned asteroid samples from Ryugu in 2020, is now on an extended mission to fly by a near-Earth object in 2026 and rendezvous with a different asteroid in 2031, adding to Japan's contribution to global asteroid science. The 3-week period in January 2025, when 2024 YR4 reached peak impact probability, was the first real-world test of every detection system, communication protocol, and government notification procedure NASA and its partners had built over decades. NASA confirmed the alert revealed specific gaps, particularly in how quickly telescope time could be redirected to observe a newly detected high-priority object. JWST observation time was requested and approved in an accelerated timeline, specifically because of this event. The fact that 2024 YR4 was discovered just weeks before its close approach window and took weeks of follow-up to resolve underscores exactly why the NEO Surveyor Space Telescope is considered critical infrastructure for planetary defense. Humanity now has one confirmed working asteroid deflection technique, the kinetic impactor, proven by DART in 2022 and confirmed by follow-up research through 2026. That is the most important fact in the entire history of planetary defense. What remains incomplete is the detection coverage. Only 40% of dangerous near-Earth asteroids larger than 140 meters have been found. The NEO Surveyor, once operational, is designed to find the vast majority of the remaining unknown objects. The goal is not to cause alarm. It is to be prepared. The science is real, the systems are real, and the progress since 2022 has been extraordinary. For the first time in history, Earth has a tested, proven, documented plan. That is tomorrow's science.